Good morning, Math 7. How y'all doing today? Happy Monday. Hope you guys are doing well. This is our last week before spring break, and we have a couple more lessons to go through. Today's lesson, we are cracking the code on word problems. I've got a whole page of definitions. So whenever you see these types of words, it's talking about these types of operations. So hopefully this helps. Again, I've got plenty of practice problems, and I also am happy to receive any questions, comments, emails, whatever you guys may have to help you in your quest for understanding. So let's get started. So again, like I was saying, these are words and phrases for different math symbols. Forgive me on what I was doing here. Again, math symbols. The first one talks about addition. So, whenever you see these words, phrases, this is talking about addition. Whenever you say something, for example, this is increased by something else, it's talking about addition. Okay. Moving on. If we have any of these phrases, it's talking about subtraction. So this subtract that, this fewer than that, it's talking about subtraction. This should be a period. I don't know why it's not. Why, yeah. Okay. We've got some multiplication. This times that, this doubled by that. When you see doubled, it's talking about 2 times. Tripled is 3 times. Twice is also 2 times. 2 times, right? Twice of this is that. Twice of your age is my age, just about, right? We have the word of multiplied by. So all these different phrases indicates multiplication. Yes, I am going fast through this, but you guys could pause the video now, so now you got no excuses, okay? All of these indicate division. Half is, of course, divide by 2. Ratio, we've been talking about ratios for a long time. Ratios indicate a fraction, right? Percent, you're going to divide by 100. Okay. Now the last one that I want to talk about, oh, I'm sorry. We have, so this times that is this, right? So whenever you see is or any different, right, these are different tenses of is, they are, right? Same as is. It's talking about equal signs. But the last one that I want to talk about, like I mentioned, is grouping. So when in our sentences, and I do have examples, but when you see these phrases, it's talking about how there's going to be a group on the next little phrase. So just keep an eye out for anything like this. This first page is probably going to be a really helpful hint for you guys, so that way you can hold onto it and be able to master these word problems. And I have an example for this last one. It's important to know that whenever you see than and from, you switch the order around. You'll see me do, whenever I see one of these words, I'll just draw these little arrows indicating that I'm going to change the order. Here's what I mean by that. Okay, so in this first example, we have 9 less than 6 does not equal, right, that's the equal sign with a slash through it, does not equal 9 less 6. Wait a second. 9 less than 6 does not equal 9 less 6. And here's why. Because I'm going to go through, and whenever I see these phrases, I'm just going to write what I see underneath. 9 less indicates subtraction. Than, that's where I switch things around. 9 less than 6 does not equal 9 less 6. Well, 9 less than 6 looks like, because I'm going to switch the order of 6 and 9, right? 9 less, so there's subtraction, but than changes their order, and that's why 6 minus 9 is negative 3, and that does not equal 9 minus 6. Okay. Here's some practice for you guys. The quotient of 14 and 8. Now, for this one, quotient is talking about division. So I've got 14 and 8. Now, I do have it in the notes that and indicates addition. But because we have this phrase before these two numbers, this is where I'm going to place my operation. So the quotient of 14 and 8, because I'm saying the quotient of, that means that this operation is going to go in between these two numbers. Okay. Now what's nice is, as of right now, we're not solving it. So this 14 divided by 8 is our answer. Oh, Mia, I could just hear you say, oh my gosh. It's okay. We could do this. Again, I'm just finding my phrases based on the whole list that I have here and doing my operation based on the numbers, okay? Let's go over this one again. 8 increased by 30. Well, increased by means addition. So 8 plus 30, bada bing, bada boom. And we're just showing the expression, right? We're just showing what it looks like. Okay, here's another one. Well, when you see the phrase a number, well, that's when we use variables. So in this case, here's an example. The sum of a number and 8. Well, the sum of is addition, and so I'm going to have a number. The sum is going to go in here, so the sum of a number and 8. Now, I could have used any variable there. For example, on quizzes or tests, if you turn it in, but in these places you put x plus 8, well, that's totally fine. That's still a variable, isn't it? All right, here's some more practice with our variables. The product of m and 15. Now, for this and, am I going to put addition there? No. That's where I'm putting this operation sign. This is the product of m and 15. So I could write m times 15, but we know that with multiplication, whenever a variable is involved, the number goes first. So 15m is the official answer. Now, if you put that on a test, it's technically correct, so I'll give you your full credit, of course. But this is what you're going to see more often. A number decreased by 5. So a number, which is our variable, decreased is subtraction. So n minus 5. Okay. Here's another one. The quotient of negative 7 and a number. So quotient is division. Now, because negative 7 went first, that's going to be my first number in the division. It comes first, therefore it goes first. I'm not switching their order. This comes first, boom, -7 divided by x, or any number. And again, 19 more than a number is going to be more than is addition, so n plus 19. Now the reason why 19 isn't first is because my word than switched their order. Yeah, technically 19 plus n would still be correct. But that's just because it's addition. However, more correct is than switches their order, n plus 19. Okay. Few more examples for you guys. Okay. Now, this is where it gets a little bit more tricky, because with algebraic expressions with two or more operations, the order of those operations matters. How it's said in the sentence matters. Keep an eye on that. Also, a comma, whenever you see a comma in the sentence, it indicates that the operations before the comma is first. You might need parentheses. Here's some examples. 4 times j increased by 3. So here's my comma. Anything that happens before a comma comes first. And depending on the operation, you might need parentheses. Well, we know that multiplication comes before addition. So this is just going to give me 4 times j plus 3. Like I said, because multiplication comes before addition, we don't technically need the parentheses here. It's still correct. And then 4j plus 3. Ooh, that's a really good looking j right there. Okay, here's another example. A third of a number minus 2. A third of a number. Well, a third is 1/3, 1/3. A third of a number minus 2. So I'm taking a third of this number and I'm subtracting 2. Now, in order to find a third of something, right, if I were to offer, Nicholas, if I were to offer you a third of my pizza, I'm going to take my pizza and divide it into 3. And then you get one of those thirds, right? You could write a third of a number as n divided by 3, but you don't have to. Either one of these is correct. Same with this first example. Any one of these 3 is correct. Whichever one makes most sense to you, do it. Okay, so this one I have even a few indications, but this has a couple different steps. So 4 added to the product of a number and 5. Okay. Now remember the first several examples where it had the product of a number and 5. So the product of a number and 5 needs to be connected. This is product is multiplication. So we're going to multiply a number and 5, and 4 is added to that product. So product of a number and 5 is going to be 5n, and then we're adding 4 to that. Okay. Now, I'm going to make up another one here off the top of my head. And I'm going to go through the process of, let's say, twice the sum and 4. Okay, so here's an example. Twice the sum of a number and 4. Now, what this looks like is in my process, this is how I do it. Twice, I know that it's going to be 2 times. Sum is going to be addition, but it's these two. So it's a number, n, and 4. Now, am I doing 2 times addition, n, 4? No. What I'm adding is a number and 4. Well, multiplication comes before addition. So that's when the parentheses comes into place. So I'm going to have n plus 4. Now, there's a few different ways I could show this, but I'm going to put my 2 times on the outside. If I wanted to show it as n plus 4 times 2, totally correct. If I wanted to show this as 2, n plus 4, also totally correct, right? Because 2 on the outside of a parentheses means that I'm going to multiply it. Any of these is correct. However, it works best for you. Again, long video today, but there's a lot to cover. Word problems are tricky for all of us. So if you have any questions, comment down below, email me, or in Google Classroom, we've got the ability to write comments and ask questions. Please utilize your resources. Otherwise, I'll assume that you guys are doing well and enjoy your Monday. Bye.